Hi, I want to talk a little bit more about the physics of baseball with an example of applying the ideas behind terminal velocity. Now, as an object moves through the air, it experiences a resistive force, and for something with a low Prandtl number like air, that resistance goes like 1/2 times the drag coefficient of the object, which is sort of like a dimensionless fudge factor, for lack of a better term, talking about how strong that resistive effect is, times the density of our fluid. The density of air is about 1.21 kilograms per cubic meter at sea level and standard temperature and pressure. It depends on the cross-section of the object that we have, and for a baseball, the diameter of a baseball is about 74 millimeters on average, or 0.074 meters, and the cross-section of a sphere is a circle, so the area of that circle is pi over 4 times the diameter squared. And then the resistive force finally goes like the speed of the object squared, and it's in a direction exactly opposite the direction of the velocity. So if I take an object and I just throw it and it's traveling forward and in any other possible direction, so here it happens to be traveling forward and down, there would be air resistance taking away that forward motion gradually. And as the object is moving down, there's an upward component to that air resistance that would be pushing against the weight of that object. So if we had an infinite flat space that an object could move through, eventually its forward motion would go away. Eventually, if it's moving up, it would have to stop, because as it goes up, the air resistance works with gravity to slow that object down faster. And then, as it starts falling, that air resistance opposes gravity, and eventually we would settle in where the velocity of the object would be straight down, such that the resistive force exactly equaled the weight of our object. That's what we call the terminal velocity of our object. So, just because an object is in air doesn't mean there's air resistance. Anything that starts falling from rest does not have air resistance. All objects begin in free fall if they fall from rest. It's just the faster that object falls, the larger air resistance can become. And similarly, the terminal velocity isn't the fastest speed an object can move through the air, because for a baseball, the terminal velocity is 80 miles per hour. And an elite major league pitcher can throw a baseball so it leaves their hand a little bit above 100 miles per hour. So what happens if we're greater than the terminal velocity, then the size of that resistive force is greater than the weight. So an object that starts falling faster than its terminal velocity is going to slow down to the terminal velocity rather than increase its speed to the terminal velocity, like when it falls from rest. So what I want to do is calculate the drag coefficient for a baseball. Now, to do that, we also need to know the mass of a baseball, because our resistive force has to equal our weight. And the mass of a baseball is about 145 grams, 0.145 kilograms. And 80 miles per hour in metric units is about 36 meters per second. So, I take my resistive force, 1/2 times the drag coefficient, times the density of air, times the cross-section of my baseball, times that terminal velocity squared, and set it equal to my weight, the mass times the strength of gravity. So to solve for the drag coefficient, I multiply both sides by 2, I divide both sides by the density of air, by the cross-section, which I said is pi over 4 times the diameter squared, and I divide by my terminal velocity squared. So my drag coefficient, 2 times 1.45 kilograms times 9.8 meters per second squared divided by 1.2 kilograms per cubic meter divided by pi over 4 divided by 0.074 meters squared and divided by 36 meters per second squared, I end up with a drag coefficient of about 0.42. Now, for a perfectly smooth sphere in an ideal fluid, the drag coefficient we'd expect to be 1/2. So, one of the things that the seams on a baseball do, in addition to giving a pitcher a slightly better grip on the ball, they also slightly lower the drag coefficient, and the more texturing you add to a surface, the lower that drag coefficient can become, which is why golf balls have dimples, and part of the reason why tennis balls have fuzz. Both of those help cut into the effect of this resistive force. Thanks for watching.